3:30.
We get it worked out.
Okay. If we're all ready, we'll move on to the last chapter. You can do it. Faith. Bus extrication. So, the Federal Motor Vehicle Safety Standards, a passenger motor vehicle designed to carry more than 10 passengers in addition to the driver. So your class 4 will get you 7 passengers, but this is class 2 for bus driver. Okay. Variety of these buses, of course, come in a huge variety of sizes and configurations once we get down to them all. At least one entry exit door, at least one additional emergency exit, usually at the rear of the vehicle, may or may not be the exit door. Could be those kick-out windows or whatever. Type A.
I'm already on type B.
Passenger capacity 10 to 20. Type B, 16 to 24 passengers. Engine beneath the windshield and or beside the driver's seat. Type C, gross vehicle weight of more than 10,000 pounds. Engine compartment protrudes from the front. Door entry, exit door aft of the front fender. Type D, full size with boxy appearance, so that's a cab over. Entry, exit door forward of the front wheels, so this would probably have emergency windows. Two basic construction methods: integral, body and chassis formed as a unit. Body on chassis, body and chassis manufactured separately and joined. School bus skeletal system forms the basic structure of the bus. Sidewalls comprised of vertical load-bearing frame members serve as partitions between window openings and very hard to cut through. Rear skeletal system. Similar to sidewall, additional reinforcement installed for protection from the rear end collisions. Framework consists of 11 to 14 gauge steel frame members called roof bows, spanning from side to side. The roof structure may contain insulation and electrical wiring. When breached, locate bows and stringers by using rivets as a guide. Does that make sense to everybody? Those would be the strong points, right? So either avoid them if you're cutting or use them for stabilization, right? Emergency escape hatches open with the release mechanism, maybe forced. Okay, school bus floor and undercarriage. Full-size buses, heavy-duty vinyl or rubber flooring applied over plywood decking and 14-gauge metal flooring panels. Strong. Smaller conversion type half or 5/8 inch plywood sheets on top of existing floor. Undercarriage reinforced with 8-gauge angle bar, 12-gauge channel stock, and 14-gauge sheet metal. Forcible entry difficult and time-consuming. So don't go through the floor. If you do, go strong. School bus front doors. There's two types, A and B, stock versions. Nader safety locking mechanism. Sounds like that might be easy to forward folding or two-door.
It's a normal school bus, the one on the right. Yeah. One folds like a bifold door. And then the one in the blue has the two.
Opening and closing mechanisms vary by age and by style. So actually, we would have to assume that this might be very tricky too to get in or out, to get open. School bus rear doors. Number varies by the type of the bus, if it's even there. Open outwardly by manipulation of lever to release the latch mechanism. Secured by 1-point or 3-point latch systems. May have additional exit along driver's side, easily accessed from exterior. School bus windows. Vertical posts between can be removed with power shears or reciprocating saws. They're made of laminated or tempered safety glass framed in extruded aluminum, split sash design. Provide an opening of approximately 9 by 22 inches, 1.5 total window area. Emergency exits are identified by hinges along the top side of the frame. Windshields made of laminated glass secured by multi-piece rubber mounting gasket. Does that sound like a gasket just like truck and trailers that we can just remove the gasket and the windshield falls out? Sounds suspiciously like that to me. Keep that in mind. Seats, 2 types of seats, driver's seat and then the passenger seats that we've all had experience with, I'm sure. Certainly don't want to try and pop those either. I've tried that in the bus that we have out back right now. We'll be able to take a look at it this weekend, I'm sure. So school bus batteries. Location varies depending on the type of the bus. Separate battery for electric lift systems, usually located on the driver's side. Okay, now we're going to go into transit buses. Transit buses carry high potential for accidents and casualties. Most commonly found in urban or metropolitan areas for mass transit.
Marshall, I got a question here. Does Alberta require seat belts for the passengers?
Right after you said it.
Somebody's phone just rang, for those who didn't hear that. But
Not for a school bus, though.
I don't believe so for a school bus, no. But for a transit bus, I think they might have to be manufactured in the bus, but I don't know that it's a requirement to wear them.
You do have them, but it's not really required.
We can maybe fact check that and get back to you.
you say okay. Thank you.
Right after you said it.
Articulated transit buses. I don't know if we've all seen these. Certainly, metropolitan areas have lots of these. They're used to reduce frequency of bus services because they can carry more people. They can carry more people because they maneuver because of a flexible middle. Tractor trailer section connected by a pivoting joint, enclosed by large bellow-like seals. Configuration can vary there. You can have a puller, 2 separate engines, one in the middle of the tractor, one in the rear of the trailer, or a pusher, a single engine in the rear of the trailer. Integral body construction, undercarriage structure, longitudinal beams that support horizontal and vertical beams made of carbon steel, mild steel, and other materials. Sounds like the undercarriage is tough too. Transit bus doors are 2-piece. Again, the opening mechanism varies, so very vague on opening mechanisms. Accommodation features, lots of hydraulic lifts now, so the buses can kneel to ease passenger loading. Okay, so the glass is commonly most common material is laminated safety glass. may have tempered glass, plexiglass, or other synthetic materials. Windshield and rear windows, similar to school buses. The windshield typically two-piece design with the gasket. Side windows, the design varies depending on age and the manufacturer. Transit bus seats, molded by plastic, yada, yada, yada. There is no standard layout for city buses. All depends on manufacturers, etc. Transit bus aisles varied in width and stuff like that. Transit bus batteries, usually located on the driver's side, forward of the rear wheels. Grouped together on a tray that can be pulled out. There's a battery master shutoff switch, interrupts power from the batteries when in the off position. Commercial buses.
Marshall, can I just interject for just 2 seconds?
Yeah.
So according to Transport Canada, there is a study right now looking at the proposed regulations for Canadian school bus operators to install seatbelts. In the last 20 years, only one child there's only been one child fatality in 20 years, and that particular fatality would not have been saved by a seatbelt. And because if they even tried to retrofit old buses, they could only do lap belts, which they said in a rollover situation, due to the size of children, would probably incur more injuries. So until school buses can be built to incorporate lap belt, shoulder belts, it's just in the proposal stage or in the fact-finding stage right now. So, and that was as of June 2017.
Wow. So even if it happens, it will probably be grandfathered in. Okay. Commercial buses. Designed to transport large numbers of people over long distances. May include bathrooms, kitchen, and sleeping areas. Integral construction. Frame covered with sheeting. Panels may not be riveted to structural members. Floors are 1/2 to 3/4 inch plywood covered with a composite rubber or other synthetic covering. So maybe those floors you could go through. Commercial bus doors. Single door at the front. Operated by air operated opening mechanism. Emergency releases inside, near top, and in the front wheel under or to the left of the door or below center of the windshield. So it's saying here that at least there is a emergency release. No emergency exit doors, but we're pretty sure that there would be windows. Commercial bus windows, side windows, single piece. Some can open in an emergency. Exit windows open by lifting the horizontal bar across the bottom. Push the bottom of the window up. And then help everybody out of the bus before you leave. That's what they say in an airplane anyway. Commercial bus seats. Individual bucket type seats. Bus aisles. Uniform width. Yeah. Luggage compartments. Okay, this stow small carry-on luggage, open shelves or enclosed cabinets. Because of these storage compartments, they reduce the ceiling height above the seats, create working space difficulties. But having said that, the large luggage compartments are near heavy fuel loading areas by the gas tanks. They may need to open doors on both sides when attacking with fire. Pike poles can pull or push cargo out of the storage area, and you get better ventilation that way anyway, I guess. Emptying can lessen overall fire damage, make extinguishment and overhaul easier. Commercial bus batteries, location varies. Electrical disconnect switch located in the battery compartment. So they have a master switch as well. Any questions with that? We do have a school bus. Our fire chief located a school bus that we'll get to play around with this weekend. So and they're tough. Definitely want to use windows if possible. Specialty buses, type AB school buses, conversions. Commercial bus conversions. It's the same vehicle. May have kitchens, may have cooking and stuff associated with it. Bus fuels. Gasoline and diesel. They're located in the rear for Type A and B buses, maybe as large as 180 gallons, 720 liters. Located midship or slightly ahead for Type C and D transit commercial buses. Fuel filler located on passenger side, just behind the front wheels. Alternative bus fuels would be the same as other vehicles. Liquefied petroleum gas, compressed natural gas is possible, and I know we're going to get into just a little compressed natural gas. Is that lighter than air or heavier than air? Lighter than air. Okay, so that's kind of nice, right? Just in case. And liquid propane? Heavier than air. Hybrid buses. Okay. So I guess with a hybrid bus, these are actually quite popular because as far as buses go, I know I visited Quebec City and they live on a hill, and it was like at least half of the energy was used or was gained as the bus went downhill. It essentially charged itself going downhill enough that it could make it back up the hill. So it never needed fuel. Pretty amazing, depending on your circumstance. So hybrid buses designed to reduce hydrocarbon fuel consumption and improve air quality. System components can include vehicle propulsion system, a diesel or gasoline-powered internal combustion engine, a battery system to store the electricity, and an electric motor or an electric motor used to run the bus on level terrain or in tunnels. System configuration. So when these motors are used in series, internal combustion engine runs generator that provides power for the battery or electric motor. When they're in parallel, the electric motor and the internal combustion engine both connect to transmission to individually or simultaneously provide power. Does that make sense? Just another note on electricity. If your transit bus is powered by electricity, you want to avoid the use of access to the roof, period. So if you can stay away from it, do. Okay, learning objective 3. Explain specific size-up concerns related to bus extrication. So, anybody want to jump the gun on that? Essentially, so what are the hazards associated with bus extrication?
People throwing out underneath the bus, in the bus.
Okay. Patients self-extricated.
Number of patients.
The number of patients. Some of those are 66-person buses. What else?
Fuel.
A large amount of fuel, at least, yeah. In the case of a leak. Maybe it could depending on the forces exerted in the collision, that could definitely be an issue. Most of the buses that I've seen have been strong as skid houses, though.
So if they're strong, then difficulty.
They are hard to get into, yeah. Yeah. So you exit emergency exits the windows, right? So if it's on its side, then maybe you consider the front window or going in on top, right? Use a ladder. Rescue personnel concerns may require more ambulances and EMS personnel to provide first aid. Space restrictions may create the need to clear less injured patients out of access ways first. Bus stabilization on the wheels, chock to wheels to prevent movement. Supplemental chocks with a chain cable, an anchor, so a chain, a cable, or webbing attached to the bus, and a bomb-proof anchor point if it's on a slope. Suspension systems are common suspension systems: leaf and coil or spring. Air suspension. The chassis could drop without warning if the air pressure was lost. Do not use air inlet valve to reinflate. Mechanical suspension, treat as air suspension. Jack plates. So these buses are provided with jack plates. So if you can find those in the undercarriage, then use those for your cribbing, right? Makes sense. They're located, commonly located under the body between two rear axles and the back of the front axle. Support all four to completely stabilize. So in these circumstances, our cribbing, our 4x4 posts may not be able to support the weight. A minimum must be large enough to support a minimum 6x6 inch post for cribbing for a bus. Hydraulic jacks. There's a tube welded on the axle near each wheel designed to accept the shaft of a jack to prevent slipping. Engine supports can be jack points. And again, lift an inch, crib an inch. Okay, so bus on its side, stabilizing a bus on its side. The goal would be to create as many points of contact as necessary to prevent sudden and unexpected movement. So we'll be using the same tools: cribbing, step chuck, shoring jacks, or a combination to stabilize. Hazards associated with a vehicle on its side are the same: the fuel and other flammable fluid leaks. The battery compartment might be on the underside, so it may be inaccessible. The fuel supply valve may be inaccessible. You need to provide fire protection with no less than 2 38 mil hose lines with foam capacity. Bus on a roof stabilization. Rounded contours will require installation of multiple step chocks or other similar devices along both sides, perhaps both ends.
Let's roll our bus.
Buses in other positions stabilizing. Situation dictates the means needed. Rescuers must be trained in use and adaptation of all available tools and equipment. Okay, hazard control. Objective 5. Describe common hazard control procedures related to bus extrication. Power shutoffs. Disconnect battery. Eliminates possible ignition sources. De-energizes power equipment. You can operate the battery master switch. You can disconnect or cut battery cables. You can shut off the engine first before you do that. Use the ignition key or ignition system switch. Shut off fuel system, main supply valve in an alternate fuel system. Engine stop switch is usually located on the driver's console and near the engine compartment. Discharge CO2, halons, or halon replacement agents into the air intake located at rear corner only as last resort. Everybody know what that is? So that's using inert gases. So to remove the dangers of sparks and stop flame. Because you're using CO2, halon, or halon replacement agents. I think argon works too. Nitrogen works. You put this gas into an environment and you can't have a fire because there's no oxygen. Does that make sense? I know we're not prepared to do that, but type A and B batteries located in the engine compartment. Separate battery for handicap lift will not interrupt power to engine. So type C and D batteries are located under the hood or a separate compartment on the driver's side. Use a hex key or Allen wrench if needed. Fuel leaks, control with Class B foam. Shut off main supply valve to interrupt the flow. Ventilate the area with intrinsically safe fans in case of LPG or LNG if needed. Down power lines. We all have the 10-meter rule down pat, right? We'll be talking to ATCO. Do not touch vehicle in contact with, even if a victim can be seen through the windows. Do not assume power line is de-energized or attempt to move off the vehicle. Cordon off area while waiting for utility service personnel. Announce the presence of down line over the radio and public address system or bullhorn, so everybody knows. Including the people in the bus. Okay, interior access, doors. Again, try before you pry. See if you can get the doors to operate using their normal operation. Some may have the emergency button located below the center of the windshield to open, maybe located on exterior of A post in front of the door. So this may be a thing where we can put a rescuer into the vehicle, and the rescuer can gain access for many more people and patients. Does that make sense? So again, we can remove the windshield with that by pulling that gasket. Ways to open air actuated controls. Reach through the driver's side window and operate the main switch located to the left of the console. Use backup release in the stairwell inside of the door, then manually open. Okay, so when they won't open, center opening doors. You can pry open by inserting your spreaders between the two overlapping seals about halfway up the door and forcing each half. Then you'd obviously have to crib that open, right? Keep it open. You can cut them apart, disconnect, and disassemble. Drive the wedge of a Halligan into the hinge with a sledgehammer to break the hinge. Cut or detach the pivot control arm. Side openings with hinges in the middle, and on one side you can insert the spreader between the non-hinge side and the frame and force toward the hinge side to open it, and then crib it. Creating a wider space to get patients through. Cut through a post at the top of the windshield opening. That'll give you the whole windshield and the door. Make relief cut in the bottom of A post at floor level. Insert a ramp between A and B posts parallel to the ground at top of the dashboard level. Extend ramp to push the wall forward. That really helps. So rear doors, you can pop them with spreaders. Again, you can use the hinges or the nadir pin. They may need to be propped open. So use the windshield access. Use the windshield access if you can't get in the front windshield. It gives quick access to the interior, provides route for removing patients. To remove them, cut the rubber mounting gasket, remove the pieces, pull all glass in. Remove the center posts. There you go, Bob's your uncle. Side window access may be difficult due to the small size. You can pry them open from the outside with a screwdriver or a rescue tool. You can go through the access hatch, reach through to open from the inside, open the window, enter, and open more. Okay, side wall access. May be necessary to force entry through the side of the bus when it's upright. Front and rear exits are unusable. Remove seats before opening the wall, so you would be inside already. Unbolt the seats from the floor. Cut steel tube seat frame. Remove windows and posts. The best tool for creating a large hole is a reciprocating saw with a 6-inch metal cutting blade. An alternate method would be remove the entire sheets of metal by popping rivets or welds with an air chisel. That usually leaves those beams. So you'd still have to cut those beams. And it says to only use as a last resort due to slow speed and noise. Roof access, necessary when the bus is on its side. Escape hatches, first choice for patient removal. Pry off to force from outside. Opening may be too small, only up to 2 feet. Cutting and opening. The location depends on the location of patients inside, position of the bus, types, and an amount of damage. Difficult and time-consuming to cut these. Offers complete access to the interior. An air chisel only cuts 1 layer at a time. Double amount of the time needed. And plus it still has to go through those ribs. So the air chisel wasn't my favorite choice. The reciprocating saw probably does a better job because it goes through all 3 layers.
Yeah, you can see on the red truck out back on the weekend that we tried to do the sides, and you can see where we ran into the braces.
Yeah. The air chisel doesn't like those.
No.
So this floor is strong too. So only as a last resort to go through the floor. Inverted fuel tank presents high risk of flash fire when cutting. Transit and commercial buses, you'd have to go through 2 floors because you'd have to go through that storage compartment first. Rear wall access.
Back door, I guess.
Or first, then
And then the whole door, yeah.
the wall out. You get lots of room.
Yeah, remove 1 or 2 rows of rear seats for greater interior access. Hey, is there any questions on this chapter? So that's it for tonight. Thank you for